This is the fan motor I've been working on this design to cool off my system. I just wanted to show you. If I can get it, I have to hold it just right. I don't have it really assembled properly, but I can hold it in a way that it does work. You can hear it. No, I didn't have it in right. There we go. Now we're cooking. You can hear that thing just take off. And what it's going to do, this is all going to get closed off by the side, okay? But what it is doing here, as you can see the shape there, that is the inlet. It's sucking in right there through the center into the core of this fan. It's turning so fast it creates like a tornado on the inside, and it's pulling the air down into the body from that hole, pulling air in. Then when it gets down into the fan, it's spreading, it's going so fast, the centrifugal force is pushing it out. And when it pushes it out, there's only one way out, and I can't really show it very well, but there's a hole right there. It's a little shrouded by this plastic. I need to trim it. I didn't quite make it big enough. I got to add more to it. I'm going to add a snout-like to it, and that's the outlet. And that outlet, this is going to be fitted into the tender at the back wall like this, okay? So it's going to be pulling in from the PC boards, which are sitting out here, and it's going to be pushing this down, and it's going to go down into like a fan-shaped plastic that mounts over the opening that we have for the exhaust. So this is going to be an air pump fan that is going to suck the hot air off of the top of the PC board and create airflow inside the tender, and it's going to push it out the bottom just like the smoke comes out the top of the stack, and I'm sucking air in from the side. This is the exact same concept because of this unique fan and the fact that we've got this tiny motor going about 10,000 RPM, and I think I'm going to be able to dial it by temperature, and then we'll have a thermistor controlled heat. So as it gets hotter, it goes faster. As it gets cooler, it goes slower. So you're not going to hear all the racket unless you need it. It's not really that loud. I'm not holding it very steady, so you're hearing a lot more noise. Usually it's a very low hum is all you get out of it, is a low hum. Yeah. So anyway, I thought I'd show this to you. I got my camera still. You notice that? I'm using two hands, and I'm just talking. My phone is actually cantilevered over the edge of my desk on top of a tender shell. That's how you're seeing this. You got to improvise sometimes. But I can show you. I can take this over here right now. I can take this over here and show you how this will fit inside the engine, inside the tender. It'll fit just like that. You see it. And there's that opening. It's going to pull the air in and push it down. And that's how it's going to fit, just like that. It's really fun. And since that's the same motor that I use for the smoke, you know, I have some of them. And what I'm going to do next is break this assembly into two pieces. So this would be their fan. There's the clearance for the fan, and this will be the inlet and outlets back here, and they'll have their stuff going off. And so that's how that's going to look. I'm sort of in the middle of sitting here, but it's upside down. If I do this, then I can rotate it for you. There you go. Now you're cooking. That's what it would look like. That's what it'll look like. It'll be come together, maybe glued or bolted, I'm not sure yet. The motor bolts onto that side, and that's the fan. Oh, it's going to be awesome. I think it's going to work. I mean, I can't believe it. And I'm using on this huge 300 by 300 by 400 machine. I could print the Eiffel Tower. I have printed the Empire State Building. I'm printing these little tiny parts, and they're beautiful. They're really beautiful. And that's Andy, my buddy Andy, and Clipper. Yeah, we have Clipper. Okay, that's it. I have got to work out. Maggie is all over me in a not in a good way either. Okay, bye.